There we go. All right, now we're in business. So baby names got names of babies. Uh, names got to have at least five or more instances for them to be included in our data set. So we are admitting potentially quite a few names here. Nevertheless, this is a pretty decent set of data. And what's been fun with this data set that we've been using, let me clean up my little work environment here. Let's go ahead and clean this up so we're not getting lost. And week two, yeah, we're week two. What's fun about this is that you can start asking lots of really interesting questions of the data. For instance, the number of um, males born with the name Brian, and we've spelled that two A's, Brian or Brian. And then we plotted that out. And as you can see, the instances of Brian in our data set peak somewhere in the early 1970s. I was born in 79, so roughly within the sort of like peak period here. Like the 70s was a particularly active time for babies being born with the name Brian. Um, but we can also ask other things of the data. So just to kind of get a sense of where, actually, I'm going to put this in 1972. I'm going to put this in 1972 just to show the peak. There we go. All right. So 1972 is when this peak happened. What about other names, right? So what's a popular name right now? You guys shoot me one.
Gabby?
Huh? Gabby? Gabby. Okay, Gabby. Let's do
I
Gabby.
think so.
Gabby. Is that because of the Cat's Eye song, Gabriella? And my kids have got permanently just buried in my brain. Let's do Gabby. Let's do that was a Gabrielle. Let me go into here. Gabrielle spelling variations. Gosh, my internet is slow. Gabrielle. What else? There's also Gabby's Dollhouse. Is that right on spelling variation? Let's see if we can pull some of these up. Gabriella, Gabrielle. Yeah, I don't want to go into the V's. I'm gonna throw in Gabriella. Okay, let's do with one L. Gabriella. All right, let's try these three names. So Gabby, Gabrielle, and Gabriella. And let's see what we get. So I'm gonna keep this 1972 in here just to kind of see how we compare. Um, and then it's not gonna be M, right? So let's look at F. Shouldn't be M. Could be M. I don't know any boys named Gabrielle, but let's just keep it. Let's do F. So girls born with the name Gabriella. Let's see what this shows me. All right, so in 1972, very few girls were born with the name Gabriella, but it looks like it peaked somewhere in the late 90s. And it looks like it had a little bit of another resurgence somewhere here in the late 2000s. So I think for you guys, so you guys would be like in this cohort here, right? This sort of late 2000s. So you guys are like late 2000s, right? Yeah, so you'd be like kind of in this cohort right here. I'm gonna call it what, 2007-ish, 2008. All right, there was a little bit of resurgence here. We gotta put it 2008. Let's go and put a little vertical line 2008 so we can kind of see where we're at. Oh, see 2005. Oh, there we go. All right, 2005. 2005 is a good time for Gabrielle's. So this includes Gabby, Gabrielle, Gabriella. Oh, yeah. There we go. Um, yeah, so that's not males, it's gonna be females. There we go. Number of females born with the name Gabriella and its variations. Um, so yeah, it looks like there was not a whole lot going on until 1960. So roughly starting around the 90s, we saw Gabby and Gabriella begin to really skyrocket, and it really took off in the late 90s. I have no idea why. That's another question. For the same reason, see, names just sort of come in out of fashion. You may see, maybe there was some popular movie character with the name Gabriella or Gabrielle Reese, famous model. She was kind of peaking around this time. So you may have seen more Gabrielle's born. Similar reason for Brian's, similar reason for any number of these variations. Names kind of come in and out of fashion over the years. And yeah, this is kind of a fun data set to look at in terms of what's sort of going on in the zeitgeist with baby names. I can remember when we were having, so I've got two kids, I've got a 10-year-old and an 8-year-old, and there is no more stressful period of time while you're waiting to figure, okay, well, what name do we give this kid when they arrive? Nobody wants to be one of 1,000 of the same name, but at the same time, nobody wants to give too unique of a name. If you're lucky, may have like a tradition in your family where names get passed down, or there may be a person in your family of particular importance that you want to name them after. Um, but yeah, if you're not falling into one of those categories, then coming up with a name can be a little tricky. My wife and I did a lot of back and forth on our girls' names. Actually, let's go ahead and look at that right now. I did Lillian. That's my oldest. Let's see what she looks like here. She was born 2015. All right, that looks about right. Oh, forgot about my title here. All right, yeah. So Lillian was apparently smoking hot back in the 1920s, right? Kind of died off after a while, right? And then it kind of slowly came back. Let me go and get rid of this title altogether because we're gonna be goofing with some data here. Get rid of this. Do so yeah. So you can see that Lillian had a pretty big peak here back in 1920. And then for whatever reason in the 2010s, 90 years later, saw a resurgence. Let's see, Evelyn, it's my youngest. She was born 2018. See what that looks like. Similar feature, right? Popular in 1920 and saw another resurgence in the data. What's our max data? Well, I'm sorry, what's our nearest state? It can be max, down the consonant max. What is it? Baby names. And then so 20, so this goes through 2017. So according to this data set, actually, it's kind of cool. There are more Evelyns born than Lillians, which is kind of wild. So for whatever reason, these names from the 1920s started seeing a resurgence starting in the 2000s, right? Kind of really just sort of bottomed out here in the 90s, 80s and 90s, 70s, 80s, 90s, and then just took off again in the 2000s, which, what does that mean? I don't know. I'll let you guys come up. I'll let you guys ascribe meaning to this data. So why adds everyone as names which were very popular in the 20s and then saw a resurgence in the 2010s. Why? That'll be an open question for you guys. That'll be an open question for you guys. I'm not going to try to explain that today. All right. Let's get skedaddling here. We have about an hour left. So let's go through some advanced filters here today. I feel like this is going to be pretty important for you guys. So far, we've been doing kind of one-off items with some precision, right? So by precision, I mean we know exactly what it is that we're looking for. So if I go look at the baby names data set, right? We were filtering by, popular names, popular girls' names, or popular boys' names. Um, we were, we had a pretty good sense. We're looking for specific names, right? Or we're looking for specific variations in spelling, right? So I can do, just comment this one out, do filter sex equals F and name and see us go back to here, Gabby. And Gabriella. Yeah. Right. So we had some kind of popular, we sort of knew what it was that we were looking for. Um, what if we are less certain, right? What if we don't really have a good understanding? What if we kind of know what it is that we're looking for? But right, there could be any number of possible variations at the end of it. So this can be, let me go down here. So start my notes. So far we have specific filters, but about less. Example. Oh, shoot. Example creation again. Names. Okay, so we kind of listed three particular variations in spelling. Does this cover everything? Maybe. Like maybe there's only three ways to spell Gabriella or Gabby. Um, I'm guessing there's probably more, and they probably show up in here with some frequency. And so what we can do in less good type today. Uh, Solution. We can use what's in the stringer package, which automatically gets loaded as part of tidyverse. We get a bunch of different ways to analyze and manipulate strings, right? So by strings, we mean character-based variables. So think about names. All these names are loosely considered strings, right? And strings are made up of letters. And so what if I have misspellings? What if I have incompletes? Or what if I just have like variations of what is roughly the exact same thing? And so this stringer package allows us to do all kinds of string manipulations. For instance, let's say that you have all caps and you want to change it to lowercase. If you have it lowercase, you want to change it to all caps. If you've got erroneous characters that are in your data set that are causing you issues and you want to either remove them or you want to replace them with something that's a bit more kosher. These are things that you can absolutely do. If you also have fixed width data sets, which I don't know if you guys ever, for those that have taken Stata, I don't know if you guys ever ran into those. You can add padding to, let's say, like the front of a string or the end of a string. Um, there's all different kinds of things that you can do with string. I do use these quite a bit. Um, Simply because I have data that's contained within strings that I want to extract or I want to manipulate. But for today, we're just going to look at some filtering. We're going to see if we can use the stringer package. That kind of gives you gives you an idea of yeah. So you can change things from upper to lower. You can put it to title. Um, right? This is a fairly comprehensive package of just manipulating strings. So let's go to baby names. Baby names. Let's run some examples. Actually, I'm going to do str. Let's do let's do a simple let's do str contains. Actually, str do str. It begins with show begins with in here. Second. So it begins with baby names, filter, and it is name. What? It ends with, right? Oh, it starts with, sorry, starts with. It starts with here. See what that looks like. Starts with selection helper, starts with exact prefix, match. There we go. We can do all kinds of stuff there. Let's do this. Filter, str. Let's do text. I'm just batting zero today. So name and let's do GAB. All right, so I want to have, so what this will do here, sorry for the slight kludginess, let me get my head wrapped around this. So we're going to use str detect. So what does str detect do? Str detect returns a logical vector with true for each element of string that matches the pattern and false otherwise. So I'm putting in this pattern GAB with a capital G, right? And it will pull all those instances where it detects this exact string, right? So with a capital G, so that should be the first letter of the name. And so hopefully, presumably, I should have instances where I detect the name Gabriella theory, but let's also be a little more specific here. Let's go ahead and do sex F and string detect name Gabriella. So what this is going to do is going to filter first by sex F. And so it's going to go through each and every single row of this data and it's going to test these first three letters, G, and it's going to look for GAB, right? So I should be able to pick up Gabby, Gabriella, and presumably most of the variations, right? It's kind of what we want. And if I do that, kind of view our results. So I get Gabrielle, Gabriella, right? So if I go back here, I only had Gabrielle with one L, right? I missed a bunch in here that had Gabriella with two L's. And then presumably Gabby with one B instead of two B's. That was another variation on the spelling. Gabrielle with just ending in IEL, right? So if you've got Gabrielle or Gabriella being used in different languages, let's say like the French spelling versus the Spanish spelling are probably going to be very different, right? I think they both use Gabriella. The name of the Cat's Eye song is any indication. But today we are not hands off with Gabriella. We're very much hands on with Gabriella. Let's go ahead and just copy all of this down. Right. Let's go ahead and do that. Go. It's variations. Go ahead and just comment this out for the time being. Let's leave that alone, see what this says. So in theory, what I should get is kind of what we've been seeing here with the plots, except instead of just being these three variations, it should be all female names that start with a GAB, which in principle should be Gabriella. Let's go ahead and see what that runs. It's like, so there we go. So let's go back here. So I had just barely 10,000, I think, for Gabriella. Let me just scoot back here. There we go. Yeah. So, nope, that wasn't it. There we go. Yep. So I was capturing roughly, call it 7,500 to 8,000 observations in our data when we were originally looking at Gabriella, just those three different variations. But as it turns out, there's quite a bit more in there. We actually picked up probably close to 50% more data with that, just by specifying str detect, right? So trying to pick up those gabs. And if I look at this data right, it looks like it did peak in 2005-ish. Yeah, I was peaking somewhere around 2005 to 2008. So if you recall the data from before, it looked like we really had the peak here in the late 90s and it kind of rolled off a little bit. But in reality, because of all the different variations of names, we're now picking up a much richer data set. So you kind of see what we did there? All right, we kind of made life a little easy on ourselves, right? So what are the two ways that we can kind of go about this, right? I can go through the data and I can pull down these unique names and I can sort by out in alphabetical order and hand annotate all these different variations of the name Gabriella. Or I can take the easy way and say, you know what, short of there being right some other name that starts with a GAB, which is plausible, we're probably picking up some false positives in here. With that understanding, we can just say like, we are specifying that we're just looking for the instance of Gabrielle. We identify that by any name that begins with GAB. And is born to a female, and that's how we're specifying this. So this gives us some ability to cast a bit of a wider net than we otherwise would, right? Because again, this data set's got 2 million observations in here. Are you gonna be able to pick up every single variation of every single name in this data set? Unlikely, right? But what you can do is you can just cast a wider net and specify around here, what's what all is there. Now you may ask yourself, well, what exactly am I pulling in? Well, we can actually go and take a look at that. So let's see here. Names. So what exactly all is in here? Let's do filter, str, let's do sense, and str detect, name, GAB, and let me see, let's go and pull name. I'm going to pipe this into a function called unique. And what unique does is it takes a vector and it returns only the unique instances of those elements of that vector. So if I've got a vector of, let's say, let's go do an example down here. I'm going to do C111, 222, 333, right? If I do unique of this vector I just created, it just returns 1, 2, 3, right? It just returns those unique values in your data. So if I do that, I get all of these different variations, right? Let's go ahead and so we can just view this. There we go. So let's go and just take a look at this. So I've got Gabina, Gabrielle, uh, got Gabby with I, right? I got some Y's in here, which is kind of cool. But what else do I have in here, right? I've got, let's see, Gable, right? Is Gable really kind of what we're looking for? Not really. So that's being pulled in. Gabria, maybe. Gabriona, maybe. What about Gabinelli? Or Gabriella Marie? Do we want that included in our data set? That's a little that's up for debate, and we may want to go through and even in more fine-tune our criteria here to exclude, let's say, Gabinelli and Gable. Right? And SGR, let's see, SGR, what does SGR equal do? SGR equal does, oh, I don't want, yep, XY, yep. So these two strings encode A, yep, that's right. Two different ways. All right. CSTR equal. Let's do name. Let's go back to our basics. Let's see, Gable. And what was the other one that we looked at? Let's see, Gable, Gabinelli. Let's see. Gabinelli, that's right. Gabrielli, Gabriella, Gable, Gabby. Okay, I'll keep that. Gabria, maybe Gabria. So we're going to start off with 6 equals F. I want to pull in all the Gabs, but notice how I've got this little exclamation point here. So I want those instances where the name is not in one of these three. So I want to exclude these three names from my criteria. And if I go and view that, right, I get the same thing kind of passed back here. And if I go down the bottom, I get rid of the Gabinelli and the Gables. Maybe Gabina is another one I want to get rid of. So now we have a bit more complete list of names right? By stringing these things together. So I definitely want it to be, a female. I definitely know I want to capture the gaps because that's going to be like the vast majority of my data set. But when I do that, and when I pull that in, I'm also pulling in Gable, Gabinelli, Gabria, and Gabina, which I don't want part of my return criteria. And so I can further specify that I want to exclude these four names. Does that make sense what we just did there? Did that seem a little clunky? Did that seem a little tough? No? So you could spend 8 hours a day doing this at work? Maybe, maybe it might drive you a little nuts. Like this is pretty easy. This is the dirty part of data analysis. Just to kind of give you guys a hint. Uh, just because we have a lot of tools at our disposal to pull down a lot of kind of, I mean, the thing that's doing the heavy lifting here, to use a Claude term, is this STR detect. That's our heavy lift, right? Because that's pulling in what we know about this name, but it casts a wide net. In fact, it casts a very wide net. And it casts a net so wide that I pull in names that I don't want part of my data set. And so what we did is we went through and just sort of manually inspected, what those instances were, and we just further filtered down our criteria. And so as you guys get into your internships or you're doing, if you're exploring careers in data analysis and economics and financial analysis, um, like this part is the fun part. Like this is the part where you're kind of showing how smart you are. This is the part that isn't as fun. This is the part that shows how hard you can work. This is your value add here. Like, oh yeah, but we also had to make exclusions for X, Y, and Z. And a lot of, companies will keep fairly expansive data sets of just exclusionary items, right? That when they run their queries or when they're doing filters or they're pulling in data, um, you know, y- this is like the secret sauce right here. Like this is what got you hired. This is what kept you employed, right? This is the best way I can kind of explain it. So just because we thought we pulled in everything doesn't mean that that's necessarily everything we want to keep. And so, we can do some visual inspections here to go through and uh, and further pare down our list. What else can we do? What else can we do? Let's see. Where do I want to go next with this? Okay, we actually covered a lot of material last week, so I'm just picking off like small items that we didn't get the chance to cover. We've done arranges, we've done filters, we've done multiple filters. We know what that looks like. That's fine. We've done that. We've done that. Yada 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 yada. This might be a pretty quick class. Baby names, baby names, baby names. Here we go. Invite per group. All right. Let's do some summary functions that can be a little bit helpful. Let me go and share my slide here so we can go through this together. And I'll send this out if you guys don't already have it. So here are some kind of useful functions for aggregation, right? So when we talk about aggregation, we're talking about the summarize routine, the summarize verb in tidyverse. Things like min, median, max, or you can specify quantile. You guys familiar with quantiles are? Have you guys done that a little bit in stats? Kind of, not really. Malia, you're kind of shaking your head a little bit, shrugging shoulders, kind of. All right, so you can think about the median as being at the 50%, right? So that's the part of your data where 50% of your observation, you're at the exact middle of your observation. You may want to divide your data up into percentiles. So you can think about the median as sort of being the 50th percentile. So that's your middle observation. you may want to divide up into uh, uh, 20% buckets. So 20% of your data is down here. Then you have the next 40%, the next 60%, 80, and then up to 100. Why do we want to do that? Well, that kind of gives us some sort of idea about the overall distribution of our data. So think about incomes, right? Think about incomes. Um, our incomes, do they follow a nice, neat, normal distribution, or are they like heavily skewed? Pretty heavily skewed, right? Like, and they're skewed in which direction? Like, you've got a lot of skew, like um towards the bottom, right? So you've got this large bucket, this large kind of part of your population that is going to be underneath some sort of threshold, but that may not necessarily be the way I want to represent it, right? Because if I just take a simple average, like what's the average annual income in the United States? Whatever the number is, I don't know what it is off the top of my head. It's probably not the best way to describe that data, right? I may want to describe it in terms of the actual population itself at the population level and say, okay, well, what does the first, if I were to rank, if I were to order everybody in terms of how much money they make per year, and I want the first 20% of those people, like what does their income look like? And then take the next 20%. What does their income look like? And you may find that those incomes don't really change a whole lot until you get up into these higher quantiles, like these, the top 10% of earners or the top 1% of earners, right? That's where you see these wages really begin to explode. And the reason why we want to look at that, because it's a bit more representative of what the data actually looks like, right? So if I were to like just randomly choose a person off the street, right? Would I expect their income to be above or below the average annual income? Well, if I know something about the distribution of data, right? If I know that these high income earners are skewing the average way high, right? Because their incomes are so large, I would expect that, that if I were to just pick someone at random, that their income would probably be less than the average annual income, that the median is less than the mean, right? Think about skew. So being able to choose these quantiles um, ends up becoming a very powerful way to describe our data. And we can do it the quantiles in terms of let's say deciles or terciles or quartiles or quintiles. So thirds or fourths or fifths, right? Just take our data, we sort it by our variable of interest, and then we just slice it up into even pieces, and we examine those pieces evenly. Um, we've done sums here, right? We've done sort of conditional sums, or we haven't done a conditional mean, but it's the same thing as a conditional sum, right? I just want a sum where some variable is greater than 10. But we haven't done these distincts, and these are kind of interesting. We'll take a look at these in a second. Um, and then we've got the mean. So let me pause here for a second. You guys understand there's between mean and median? Yeah. So if my you know what that means, like when the mean, so what does the distribution look like if the mean and the median are exactly the same? You're on mute, Malia. I see you giving an answer. Come off mute. There you go.
It's incorrect. I
Do
don't
what?
know if it's incorrect.
You're
Computer, sorry.
Oh, you're
Um,
fine.
I don't know if I'm correct about it, but I feel like it would be equal. Like the graph would be similar.
Yep, that's right. Yeah, I think symmetrical. You think in the term symmetrical, right? Like so it's gonna be so if I think of my distribution like a bell curve, right? Um uh I wish I had a little sketch pad in here. Maybe I do. Do I have a sketch pad? Annotate. Yeah, I want to annotate. Let me see here. Can I? Yes, I can. All right. How do I undo that? All right, so draw this. And so this is going to be, just pretend this is God, that's horrible. That's even worse. I can't draw a bell curve the same in my life, guys. Sorry. Pretend this is a bell curve, right? All right. So if I've got, this is my mean, my mu, right? And I've, if my mu is equal to my median, can I just type? There we go. There we go. Mean is equal to median. Get rid of this. This is horrible. There we go. So if my mean is equal to median, right? What does that mean? That means that everything on this side, right, is equal to everything on this side. What if I have, let's think about the average annual income, right? So my data probably looks something like this, right? Where let's say this is my mean, right? But my median is probably somewhere over here, right? So my data is skewed pretty heavily towards the left over here, right? The vast majority of my data is going to be over to the left, and I'm going to have this kind of long tail of data over to the right. And so my mean, let me go up here, my mean is greater than my, right? Example, right? So we're talking about skewness. So does it make sense to talk about things in terms of their average? Probably not, right? I've got a lot of my data is heavily skewed. And so that's where these quantiles really kind of come into play. And, again, all they do is they just take your data and they break up the observations into equal buckets, so buckets of equal size, and then you just compare what those buckets are, right? That's all you're doing. And so you're able to make comparisons about, let's say, the highest quartile of wage earners or the lowest decile of wage earners. They may have certain characteristics are of interest for policymakers. And so, those become kind of really important. So let me get rid of this. And then window functions return multiple values per group. So these return one value per group. These here return multiple values per group. So top n will return the top number of observations in a particular category. Lead and lag. I'm not really going to use these a whole lot in this class, but they are kind of important to do so. Let's say that you want to run a regression model on lagged income, right? So what does a person's income in time one, like what does that, you know, what relationship does that have on whether or not their kids go to college in time two, right? So does a parent's financial success have a relationship on their children's educational attainment? Right? And there's a lot of research around that. Like, do your rich parents mean that you'll be rich as an adult, right? Or are there other factors at play? Interesting stuff. Let's go ahead and play with some of these here a little bit. Let's go through here. Oh God, that's going to be really annoying. Let me get rid of these annotations here. How do I get rid of these annotations? Let me erase these. Get rid of all this. But they're going to stay with the document, but I guess not. All right, distinct names over time. So let's go ahead and generate some distinct names over time. It's an easy way to do this. We can do, we can summarize n distinct, right? We use an n distinct function in our summarize. So let me just scoot over to ggplot here. I'm sorry, R real quick. I don't want to do desktop. I want to do this one, share. Yeah, here we are. Okay. Let's do baby names. Desktop here. It's a little less obnoxious. We're gonna group by. Let's do year and sex. I want to see what they look like for both men or for boys and girls. Let's do a quick summarize. All right, and I'm going to call this n names equals n distinct name. And so what n distinct does, let's go ahead and pull that function up. Distinct. N distinct counts the number of unique distinct combinations in a set of one or more vectors, which is kind of cool, right? So if you recall up here, right? So I've got this unique, right, that we did before. Like, so I went here and I pulled it, did unique and then view. This is doing something very similar. So it's doing this unique operation, right? Implicitly inside of n distinct, except and then it adds a count on top of it. So what you will return is the number of distinct names within our data sets. So let's go ahead to ggplots. Line s x equals year, y equals n names, color equals sex. And let's go ahead and throw a title on here. Labs. Title equals number of distinct names. Y equals distinct names. X equals year. Do that. There we go. I get something that looks like this. So what do? Got baby names. I pipe it into a group by because I want to know for each year, but also each sex. That's kind of how I want my data to be grouped by year and by sex. Now, what do I actually want to do with that data now? Well, I want to calculate the number of distinct or the number of unique names in each year and each sex. So we use a summarize and we pipe that into, I'm sorry, we use a summarize. I'm going to call that variable n names and then use this function n distinct name. And then we just pipe it into a ggplot. We do a gm line. We do x equals year, y equals n names, color equals sex. This should seem pretty similar to you guys. It shouldn't seem too kind of revelatory. Kind of the cool thing in here is this n distinct, right? This n this operation was being run enough times that someone just broke down and created a function for it called n distinct. And we were able to use it to our advantage in this data. So let's take a step back here. I've got this number of distinct names. What do we notice here? Give me your interpretation of this data. What does this tell you?
They increase as the years go on.
Sure. That's one way. Yep. That's one good observation. But what do we notice more recently?
The distinct names are being used more.
Yeah, it kind of peaked here like in the early 2000s, right? And then it really sort of fell off quite a bit. Let's see. I'm going to go ahead without looking at the data, which is what I probably should do. I'm just going to go ahead and add a geom beeline x-intercept equals, what do you guys think? This is what, like 2007, 2008-ish in here? Let's go in 2007, maybe. Yep, nailed it. So the number of unique baby names really increased quite a bit up until 2007. and then it really fell off a cliff, right? Uh, Particularly for women, to some extent for boys, but it seemed to kind of flatline, maybe even kind of ticked up a little bit here at the very end. Um, can anyone venture why and why 2007 is important?
Was that near the recession?
Yeah, we had a really nasty recession, didn't we? We had a really nasty recession. Um, and at the time, um, there was a pretty active conversation with people's unique, the effect that names have on people's professional success. That was a really active conversation. And so these, the uniqueness of names really began to fall out of fashion right around that time. Parents were concerned that, oh, if I give my kid the wrong name, I'm going to condemn them to a unremarkable career or whatever, right? Like that was an actual active conversation. You saw those names really begin to drop. Those unique names really begin to drop off, particularly for girls, although less so for boys. And although it looks like it may even happen a little bit later for boys too. And you can kind of see something similar happen, right around the 1930s, right? These unique names kind of fall off, right? So these unique names may, they have something of a luxury associated with them, and where people feel like they may have less ability to use unique names, because economic conditions are tight and they feel like that it may put them into a disadvantage. You may see those drop off. Is that the reason? I have no idea. I have no idea. I'm just taking a swag. I'm just taking a guess. Um, but the data is pretty stark right around here, and I can't really think of too many other reasons in 2007. I mean, maybe something to do with the election, right? I mean, Obama became president. That was a pretty monumental period of time. It seemed like that there was maybe some change culturally that was happening around then, right? That was, it was that 2008 to 2020 period was pretty unique in American history. Maybe that had, some effect there, something to think about. Um, but yeah, so it's not just, okay, what data did I get here, right? But what is it that I see in this data, and what could be plausible reasons for that. Um, let's go ahead and do another one. Let's do the top share over time. So top share over time. So I'm going to start with baby names, right? And so what I want to know is for this, so I'm going to pick a number as my top 5 or top 10 names, right? So of those, what share are they of the overall data set, right? So another way to think about this is, right, each year is going to have like a really there's going to be, that's the name of that year, right? Like this is the year of the Marys or the year of the Gabriellas or the year of whatever. Um, what proportion of those top names are they of the entire data set, right? So I want to group by again, year, sex. Uh, let's go take a look at our data real quick. All right. If we notice, we got year, sex, name, and we've got these two here, right? We've got this N, which gives us our count, right? And I've got this prop, which gives us our proportion, right? This is our proportion data. So what I want to do is, when we're talking about, proportion, the share of things or the proportion of data, I want to deal with this prop category. And this prop category is pretty interesting because this prop category kind of tells us what the weight is of this name, right? So if I go back to 1880, right, Mary was, 7% of babies of girls born in the United States in 1880 had the name Mary. Like that's we can think of this as like a weight, right? So the name Mary has a weight of 7%. go arrange by prop. And we can use a function like top n, right? That's going to give us, right, the top whatever number it is of our data set, right? So give me something. Give me a number. How many top what? You know, top 5, top 10?
Top 5.
Top 5, 5. Okay, we're gonna do 5. Let's go take a look at what top n takes as our arguments. Top n. It's a new function. We always want to take a look at what's in here. Let's see. Boo, 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 boo. Ooh, has been superseded in favor of slice min, slice max. Ooh. Ooh. While it will not be deprecated in the near future, retirement means we will only perform critical bug fixes, so we recommend moving to the newer alternatives. So I'm going to put a comment there, and we want to use slice max. What does slice max do? Let's go find out. This is going to be fun. Slice max. Slice max. Slice lets you index rows by their integer locations. Thank you. Slice head, slice tail, slice sample, slice min. Okay, select rows with the smallest or largest values of a variable. Okay. All right. So can you guess what slice min does, Alyssa? It's going to return what?
I don't really understand what slice max does.
So slice min and slice max like the rows with the smallest or largest values of a variable.
Oh,
Right. So slice min is gonna return the smallest values, right? And slice max and return the largest variables. So if I have some data, and I specify an n, which is going to be the number that I want to return, and then I can throw it a prop variable, which is what I want to kind of measure against, right? So I want to return so what slice does is it returns rows. So I want to return the top n number of rows based on the values that we are passing into prop, right? So I can do slice max. How do I do this? Let's go look at our examples. Slice head, slice tail, slice min, slice max. So slice max, I want to do, let's do name. No, let's do let's do baby names. We can do n. We can do n. Ooh, this is going to be confusing. What's 10? Let's do acid 10. So what does that give me? Slice max n equals 10. No, I did not mean n equals 10. I want n as my variable, and equals 10. There we go. There we go. So if I view this, let's see, 1880, 10. That did not return what I wanted it to. Wait, no, it did. It did. It did. Aha, cool. It did. Very good. So what did we do? So I fed it. So we did baby names. We group by year and sex. Just arranged by prop, just to make things kind of nice and neat. And then we did the function slice max. And the first parameter I want to feed it is my data, right? So this is what I want to this is what I want to run my criteria on, right? And then what do I want? I want the top 10 values, right? That are in N. And so when I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So I need to get 10, and I should get another 10 for men, and then those just repeat onward and forward. So that's kind of neat. So I've returned now a data frame that has in each year the top N names for boys and girls in that year. So what do I do now? This is what it returned. So if I want to know what the proportion of these top, I think you said five, actually. Let's do five. Let's do top five names. Oop. Back up, back up. So top five names. So if I want to know what the proportion of those of the total data set, what do I do?
Is it a percentage?
Yep. Do I have percents already in here?
Yes.
Which one?
Um, prop at the
Cool.
top.
So what am I going to do with prop?
Um,
I'm going to multiply it, going to divide it.
multiply it.
Close. Keep going. What else can we do?
Divide it.
No, no, we're gonna add it. We're just gonna simply add it, right? So if you remember, like when I added these props together, right, they got something that was pretty close to 100%, right? So this is the share of all names, right? That this name was of. So Mary was 7% of all names. So if I just add, right, these numbers together, this is going to give me the proportion that the top five names are of all names in that year, which is kind of what we want. So if I just do a summarize, say top five prop equals sum prop, right? If I view that, right, I should get, right? So in 1880, the top five names comprise 15% of all names, right? So in other words, 15% of the babies born in 1880, 15% of the girls born in 1880 had one of the top five names, and 30% for boys. So roughly one in three boys born in 1880 had one of the top five names. Does that make sense? So how does that look over time? Plot it. So it goes here, y equals top, what do I call this? Top five prop. And color equals sex. We got boys and girls. And then I'm going to do a labs title equals top five proportion of total names. And then I'll do x equals here, and then y equals portion. So I do that, I get something that looks like that. So you should get something that looks like this. Right. So what does this tell us? Give me your interpretation.
I think that over time, the five um, total names were decreasing.
Sorry, you sound like you're at a McDonald's drive-thru. I apologize. Your microphone is not cooperating with you today. I apologize.
Oh,
I'm going to assume your answer was right. I'm going to assume your answer was pristine. You get a pass for today. Yes, that the most popular names are comprising a lower share of all names in any given year, right? So, what did we look at before? Number of distinct. So this is the number of distinct names, right? So this is kind of like the opposite of distinct names in a way, right? So, the number of distinct names was increasing over time. And so the number of names that were in the top five has decreased over time in a very similar fashion, right? So there's like an inverse relationship between the two, right? Is one way to think about it. We can also think about it in terms of like the breadth of our data, right? So how much of our names are clustered, right, in these top categories. Um, and it can kind of, give us a sense of what the distribution of our data looks like is a good way to look at it. And so, um, you know, are unique names increasingly important in society, would you say? Does everyone want to have the same name, or do people kind of want to have some sort of a unique name? Unique name. Yeah, names are important. You carry with you your whole life, right? Like, do you want to be another just kind of it's a joke, right? It's like John Smith, like the most generic name on the planet, right? Nobody wants to have a generic name. People, you know, it's a part of their identity. It's kind of, it's what carries with them over time. People, put a pretty high value on having a unique name. Um, does that mean that these are entirely unique names, right? Are these new names whole cloth? Maybe not so much. If we go back to, did I keep it in here? Or did I get rid of it? I may have gotten rid of it. Let's go back up here. Let's go back up to our Gabriella example, right? Do I consider all these different permutations of Gabriella unique? All right. I mean, the name's Gabriella. Like, it's a name that you say, and they all have roughly very similar pronunciations. So are they necessarily unique, right? Because according to R, it's treating, let's go back and take a look at these, right? R is treating all of these as being unique names, right? That's what our analysis is saying. These are all unique names. Gabriana, perhaps. Gabriella with a Y, it's getting a little grayer, right? Gabrielle with one L versus two L's. Ends with an A versus ends with an E. These are shades of gray, right? Do we really consider Gabby with one B and Gabby with two B's as being unique names? We may not, right? From a strict literal interpretation, from a computational perspective, they are unique. They are distinct names, right? Gabby with one B and Gabby with two B's are two entirely distinct names. But epistemologically, I think is a word, if that's right. Are they the same? Maybe not, right? Maybe not. Maybe we want to cluster these together, right? And so, you know, this is sort of where the art of data science really comes into play, right? So, and this is where like large language models and AI have really done a lot of heavy lifting for us, is that they're able to very quickly, in a very mathematical way, determine like how similar two words are to each other, um, and whether or not they belong within the same category, right? So, literally what Claude or ChatGPT are doing is they're going through all these words and saying, well, how really dissimilar are they? Or how unique are they? Like, and it sort of intuitively knows from its training data set that these are all, generally speaking, girls' names, and that they're all kind of within the same sort of shape of names, right? If you think of like names as having a shape, all these Gabriellas all have roughly the same shape. There may be other differentiating factors, right? So, are your parents Spanish? Are your parents French? And so they may have a different interpretation, right? Were you born in uh yeah, were you born in Haiti, or were you born in the Dominican Republic, right? Two sides of the same island, right? They're gonna have probably very, very different spellings. Um, but roughly, generally speaking, kind of the same name. But yeah, that's really all I have. That's my lecture for today. Giving you guys 2 minutes. I will get you guys some information on projects. I talked about a little bit before class. Um, Probably going to do something around the American Time Use Survey. This is data published by the Bureau of Labor Statistics. This breaks down how people spend their time in terms of childcare or leisure activities or working and so on and so forth. It's a pretty rich data set, and I just need to make sure how tractable it is before I hand it off to you guys. I think we're at a point now where I can probably just hand it off to you. And so the general idea, and I'll have this specified for you so that way you're not just sort of swinging wildly at data. What my expectations are, something similar to this, right? You've got data. I'll let you guys come up with a question out of the data, and I'll let you guys attack it however you want to. This is not a sink or swim thing, right? We'll have office hours around it. You guys can show me what you guys are working on, and we can go through the iterative process of refining down our question. But that's kind of the I think for this semester, for this summer, and kind of for this class, that seems like the appropriate level I think I want to hit at for you guys coming out of this. How does that sound? Does that sound unreasonable, pretty reasonable, scary, daunting, a light lift, medium, medium rare, cooked, chopped? What term do you guys use these days? But that's kind of where my head's at right now. So you should see something on that a little bit later this afternoon, probably closer to 12 when I post up all the videos. Is that cool? Cool. And you'll get some feedback on your homeworks as well. I got that. I'll give that out to you guys. That's all I got. You guys got anything for me? No? Cool. All right. Well, 9:31. Enjoy the rest of your morning, and I will see you guys tomorrow.
Thank you.
Awesome. Appreciate you guys.
Thank you.